So today we are graphing linear inequalities. We solved inequalities back in Unit 1. I think it was like 1.3, and then we did them again in 1.10, I believe. But with a linear inequality, the graphing of the line is going to be the exact same. But instead of the solutions being all the points along the line, the solutions are everything in the shaded area. Which we will be making. We will be making a shaded area.
I think I ran out of the lid.
Okay, come grab some from me or grab a different pencil if you have one.
I'm gonna get this.
Okay, solutions, once we find those solutions, get written as ordered pairs. And if you want to put a little note to yourself, x comma y, so you know x comes first. And you know what an ordered pair is. Okay, so with inequalities that we did on a number line, if you guys remember, we had an open dot and a closed dot, and we shaded left and right. We are also doing something to signify the 4 different inequality symbols here. So, how we signify whether it is a dashed line or a solid line is whether it's less than or greater than, or less than or equal to, greater than or equal to. So if it's just less than or greater than without the equal sign, we are going to do a dashed line. So we will shade below a dashed line for a less than sign, and we will shade above a dashed line for a greater than sign. Then the shading's the same. We'll shade below a solid line for less than or equal to, and we'll shade above a solid line for greater than or equal to. They're like actively working on turning the heat on. We're going to give it some time and then work on it.
Yeah, you're supposed to have that 10 minutes.
Okay, so we've got our 4 inequality symbols. With those 4 symbols, help for a second. Hey, so with those 4 symbols, how we can tell whether it is or equal to or not or equal to is whether it's dashed or solid. And then how we can tell whether it's less than or greater than is whether it's shaded above or below. Okay, and then I put a little note here. Points on the dashed line are not solutions. Points on a solid line are solutions. Okay, we're going to get started graphing, and then I think you guys will see what we mean by dashed and solid and what we mean by shading after that. So our first example, we got y is less than negative 2/3 x plus 4. If it is a less than symbol, that means I do a dashed line and I shade below it. So I'm going to put that on these 2 lines. Dashed and below. So a less than symbol tells me to do a dashed line and shade below. Okay, so then we graph that line. So negative 2/3 x plus 4. So we start at 4, just like we've been graphing lines in slope-intercept form this entire time. We start at 4, and we graph our line of negative 2/3. That means I go down 2, right 3. Down 2, right 3. And then I'm going to repeat that. Down 2, right 3. For today, for inequality specifically, you have to make your line go all the way across your graph because it has to chop your graph in half so you know where to shade. Don't connect it yet. You also are going to want to go up to left 3. The reason why I said don't connect it yet is because I wanted to remind you we are making a dashed line. So you are not just connecting those, you're going to connect it in like a dashed or a dotted line. You're going to go like this. So that dashed line is how we know it is just less than and not less than or equal to. And then after that, we shade below that line. So below that line is going to be down here. And when we say shade, you don't need to color it all in completely solid. What I do is I go against the line, and I just make some lines here so I can tell I'm being shaded in. I would shade lightly, just in case you have to move something. Because if you color in the whole sheet of paper completely black, and then turns out you use the wrong y-intercept, then that's a lot of erasing you have to do. Okay, so that's our first one. The graphing of the line's the exact same. The only thing that's new is the type of line and the shading. The next one is y is greater than or equal to 2x minus 5. What kind of line should I use, dashed or solid? Solid. So we picked solid because it's greater than or equal to. We picked solid. Where should I shade? So greater than or equal to, above, which makes sense because it's more. So we just match up the symbol, greater than or equal to, solid line, shade above. Okay, so I'm going to graph this. I start at -5. And then my slope is 2, which as a fraction would be 2 over 1. So I go up 2, right 1, up 2, right 1. And I'm going to keep going all the way across my graph to make it easier for me to connect my line. Okay, and then this one is a solid line, so you just connect it with your ruler like normal. And then we are shading above that line. Okay. Any questions about either of these guys? Okay, so we are going to go ahead and we've got 2 more on the back. The 2 more that are on the back are the exact same thing, but they're with our horizontal and our vertical lines. So go ahead and flip this over. We've got y is greater than 4. Up here at the top of my notes, I'm going to write this down as a review of yesterday. That a horizontal line has 0 slope and is y equals. A vertical line has undefined slope and is x equals. That matches up y equals and x equals. Okay, so for y is greater than 4, for a greater than symbol, I am going to do a dashed line, and I'm going to shade above it. So when I go to graph my line, because it's y equals, I guess it's y greater than, but it's the same line. We're graphing the line y equals 4. Since it's y, that means it's horizontal. So I'm going to do a horizontal line at 4 right here. And you make that line dashed. So I lay down my ruler and then I go like this. Beep, boop, beep, boop, beep, boop, beep. And then I'm going to be shading above this line. Okay. And then the last one, vertical line, because it's x. So I've got x is less than or equal to -2. So since it's less than or equal to, the or equal to is what makes it a solid line. The less than is what makes me shade below. So I'm doing a vertical solid line at -2. So this is -2 right here. That's where I'm going to make my vertical solid line. And then here's one thing that's a little tricky is the above and below on straight vertical lines. It's not really below, but it's going to be like in the negative direction. So my x's are positive this direction, they're negative that direction. So below is a little bit of a weird term. It's actually to the left, but that would be below. Because it's the x's that are below -2. So the x's of -3 and -4 and -5. Okay. Any questions right now? Okay. There's one more thing that I want to point out to you guys because you're going to need it on the first problem on your assignment. And that is what it means to be a solution to one of these inequalities. To be a solution means that you are in the shaded area. So on the first question on your assignment, and I'm going to leave this in the video so people can see. On the first question on your assignment, the graph is already given to you, and you are asked to find the solutions. So how you're going to do that is you're going to graph these points. So 3, 4, I would go over 3, up 4, put a dot there. Is that in the shaded area? Yeah. So that one is a solution. You are going to circle all your solutions, cross out all your non-solutions. Okay, the next one, -2, 3. So that means my x value is -2, so I go left 2, and I go up 3. Is that guy a solution? No. Okay. So I'll leave this up there so you've got these first two done. And I will bring around your assignments.